Hey everyone, we're back with part 2 of the High Performance 4L60E build-up series, and in this section we're going to be putting back together the forward drum. So the drum we're using is a Sonnax Smart Tech drum. This is the best forward drum on the market for the 700R4 4L60Es. It is far better, in my opinion anyway, than any of the drums that came from the factory. So the drum comes as a complete kit with the housing itself and the input shaft installed. It also comes with a ply plate and a backing plate for the 3/4s, along with the fastener kit to bolt the backing plate to the drum. And it also comes with a billet aluminum coast clutch piston that you have to use in conjunction with this drum. You cannot use the factory piston, whether it's the early aluminum style with the spring bosses or the later molded bonded steel and rubber piston type. So you got to put those aside and use the Sonnax piston. You also have to run a late model return spring, so regardless of what year you're working on, whether it be a 700R or early 4L60E, you have to use the late model that has the, it's fully caged, it has the top and bottom support. And then what we're also going to do is install Transgo high rate return springs. So one of the things we have to do is modify the drum. These drums come with the standard 3/4 bleeder ball capsule that is used on the factory drums, and the reason why Sonnax does that is because they don't want to just assume that this is going to be used exclusively in a high RPM, high horsepower application. It could be used in anything. So we'll do that first, then we'll build up the drum, and along the way I'll kind of talk over different considerations and options for setting up your forward drum, whether you're using a factory drum or this drum, and kind of take you through those different scenarios and give you some tips and pointers. So let me go ahead and reposition the camera and we'll get started. Alright, first thing we need to do is knock out this factory little bleeder valve or bleeder capsule. So with the Transgo high rate return springs, it's going to come with a little press disc for your forward return spring assembly when you're compressing it in the foot press. Here's the Transgo orifice style bleeder capsule. It's also going to come with a set of 3/4 return springs. It's got a few different kind in here. I think there's maybe 2 different kind. Always use the yellow return springs for 4L60Es. I think the white ones are for the 700R4s. And then you have your forward return springs, and these are just plain looking. And of course there's instructions. Alright, so what you want to do is you want to position a drift punch right over the capsule, and you're just going to pound it right out. I mean, that was barely in there. Nothing wrong with this capsule, just not going to be used in this application, that's all. Alright, now what we need to do is flip the drum over so that we can install the Transgo capsule. And this is really an orifice style bleeder. It'd be nice if I can get it to where it'll show you the orifice. So it's just basically a pinhole, and it will work to bleed all of the excess fluid that's pooling behind that 3/4 apply piston when you're in first and second gear, shifting it around anywhere from, say, 5,000 to 7,000 RPM. Just drop it in and fully seat it. Alright, next, install your O-ring. This separates the forward clutch circuit from the 3/4 circuit. If this O-ring is left out, then you will have third gear starts every time you go to put it in drive. Alright, I'm going to follow that up with the 3/4 piston. And then once I have this in, I'll put the little input-output shaft junction seal in, and then we'll go back to the bench so that I can install the high rate return springs into their respective locations. All right, to remove the spring assemblies here on the forward return spring, it's going to be a very simple deal. All you're going to do is kind of just lift up here on the springs themselves, and you always want to start here on the bottom. So all you got to do is just kind of maneuver it like that, and just go all the way around until you get them all off. So very simple deal. In fact, you could do this without even using a screwdriver. All right, next, I'm just going to take diag cutters, and I'm just going to twist until I can get these off. It's probably going to be a little dirty, as you can see. A little bit of residual, old transmission fluid or whatever. No big deal. I'll clean it up before I put the Transgo springs on. This is a lot easier to deal with than the 4L80E. The 4L80E direct drum return spring assembly, to get the new return springs on, is a pain. I mean, it is really, really, really tedious. Alright, just gonna wipe it down. Get any residual off. Same with this. Doesn't have to be clean such that you could eat off it or where you would put it in your mouth or anything like that. It just has to be clean so that it's not dripping with old transmission fluid and whatnot. Alright, just make sure you keep your old return springs as kind of far away from the workspace as possible so you don't get them confused with the new ones. Alright, so these springs are very slightly tapered. You're going to put the smaller diameter side and mate it with the little spring seats. And you want to snap them in just like that. Looks like I gotta change my glove out here. Like I said, this is a fairly smooth process. Doesn't take too long. These springs usually don't give you a lot of grief. Same with the 3/4. It's usually not too much of an issue. And the 4L80E, it is completely different story with that thing. It takes a little bit, I should say more than a little bit. If you watch my 4L80E build-up video, you kind of see what I mean. I didn't even film the entire process, installing all these springs, for that return spring deal. I don't know if that's upside down or not. Yeah, I think it is. Some of these springs will not actually seat fully. If that's the case, don't worry about it. I mean, it's going to be caged, so it's not like it's going to come off, or it's going to, springs are going to fly off once everything is installed in the drum. It's not going to like do the equivalent of throwing a connecting rod or anything like that. I mean, they're going to stay put. And then the only other hazard you got to worry about if you're doing this wearing gloves is having the gloves stick in the little, between the springs and the spring seats. I guess that's a risk I'm willing to take. So I absolutely hate working on these things without gloves on. You know, I'm one of those types of mechanics or, you know, techs that hates to get his hands dirty. So, yeah, that's who you're dealing with here. That's the kind of person you're dealing with. So, that's not you, but you're watching this video anyway. Thank you. All right. Just line everything up. And then when we go to reinstall this, you know, compressing the entire guts of the, you know, bottom part of the drum, we'll put this, you know, little forcing spacer over top so that we don't accidentally bend this relatively thin piece of metal here, you know, the top cage, and that'll allow us to install everything without any problems damaging the return spring cage itself. Okay, so for the 3/4, what you want to do is you want to bend this down just like this, and then you want to take this tab and you want to force it backwards. And these tabs are not, you're not going to have to worry about re-engaging, because you're never going to be able to get this hook into this location here with the new higher tension return springs installed. It's never going to happen. So you want to bend them back so that there's no risk of them interfering. And then, you know, once you have that done, you can just follow the same process you just saw with the forwards. It's the same deal. And look, some even came out for me. And these you can just pluck out, like even easier than plucking feathers off a chicken. So these are also vaguely tapered. So you want to put the small diameter side, you know, on the little, you know, on this side of the spring cage. And like with the forwards, some of these will just kind of rest in place. They're not going to snap on or snap in. I mean, you know, flip it around, make sure you're not putting it on the wrong side, but you know, some of them won't actually snap in. And again, it's not going to hurt anything. They're not going to come flying out once, you know, vehicle starts driving down the road or anything like that. I mean, they're going to be under an incredible amount of tension and locked in place with, you know, with the snap ring. Alright, I'll talk clutch selection while I'm doing this, you know, the type of friction material that's available. For high performance, it's really going to depend on what specifically you or whomever is you know, going to be using the vehicle, how they're going to be using it. You know, that's going to really drive what you decide to do when it comes to, you know, the type of frictions you put into the transmission, particularly the 3/4 clutch pack. I mean, all the other clutch packs, I mean, you can almost get away with stock level frictions. The only ones that where for high performance in a street driven application that you really need to upgrade are the 3/4 clutch pack and the overrun clutches. But you know, if you're going to upgrade those, you might as well just upgrade all of them, because it's not going to be that much more expensive, if you know, depending on exactly what you're doing. But we're using Alto high energy frictions everywhere in the transmission, so forward, overrun, 3/4, reverse input, low reverse, and we're also going to use the Kevlar band for the 2/4. So here's my opinion, or I guess guidance, if you will, for choosing a type of clutch material or friction material for the 3/4 clutch pack, because that's really where you have to make some choices. If this was a full racing application, like we were building a vehicle up for the drag strip, and it was going to be trailered to the drag strip, trailered from the drag strip, and it was only going to make passes down the track, it was never going to see the street, then I would put either Alto Reds or Ray Bestis Stage 3 clutches in the 3/4, aka Ray Bestis Blue Plate frictions. Reason why I hesitate to use those particular clutches in a factory and or any kind of street-driven application where the vehicle is going to spend the majority of its time on, being driven on the street, is because of the wear rates between high energy frictions and Ray Bestis Blues and similar style racing clutches. Now the Ray Bestis Blues will handle heat like no other. They will grab and they will hold like no other. But you have to trade off something for that kind of holding power, and that trade-off you're making is longevity. They will wear quicker. That's just the way it is. Same with the Alto Reds. The high energies, on the other hand, will not wear as quickly, nearly as quickly. They can be used in any application. Now, if this was going to be, again, an all-out race transmission, we got trans brake, we got, super high stall converter. The converter that's going in this one is going to be 3200 stall, somewhere 3000 to 3200. If you were doing like 50,000, or 50,000, yeah, 5,000 to, somewhere in that neighborhood, then, with that kind of profile, then yeah, we want to use a different type of friction. But for anything that's going to see majority of the street, I recommend you stick with the high energies because they'll handle the heat just fine. As long as the heat is managed like it should be, right? You got the right amount of fluid in there. You have a trans cooler. You're doing everything you're supposed to do in that regard. You don't let it overheat. Then they'll be fine. A few passes down the track, it's not going to hurt it. But if you're racing on like a regular basis, maybe every Friday night or something, you got like. Say you figure to run, 26 times a year or more, that's roughly half the year down the track, then I would probably go with the Ray Bestis Blues because they're going to give you that little bit extra holding power in 3/4 at the added trade-off of increased wear rates. Racing transmissions are basically a wear item. It's expected that you're going to have to periodically take it out and refresh it so that you can get it ready for the following season. On a street-driven vehicle, yeah, that's not the case. All right, so when you have your return spring assembled, just drop it in carefully. I should say lower it in, don't drop it. Just lower it in. Okay, make sure it's in there good. And then we'll go ahead and lube up the forward piston housing so that we can put the forward piston in it and place that into the 3/4 ply cage. So other options for streetable, like street strip applications and streetable, drivable, everyday type frictions are going to be the Ray Bestis GPZs, the Ray Bestis Stage 1. Of course, you could use Borg Warner High Energies. Those are fine too. So those are the others that I'm most familiar with and use all the time. So they're all good frictions. Exity, they make kind of stock level frictions. They may make some high performance stuff. I know their stock level modules are made in China, and I know Ray Bestis is made here. For me, that's important. It may, you may feel differently about it. I don't know, but I'd rather use stuff that's made here, especially if it's going to be for like a high performance type application. Okay, we're ready to go ahead and insert this into the drum. So I like to use a little protector tool. So take the camera back over to the foot press and we'll get everything in there, and then we'll finish up the build on the foot press. Carefully lower in your assembly. And again, it's going to be under a lot of tension. So you may have to make a little bit of an extra effort there, like I had to get it to seat. That's fine. All right, now we're going to grab our aluminum piston. This is going to take an O-ring on the inboard seal, or for the inboard seal, and then a traditional lip seal for the perimeter. So lip seal is going to face down. So just install it, make sure it's in all the way around. And then lube everything up here on the surface, the journal and the piston itself, forward piston, and then lube up your coast clutch piston. So lip seals, sealing ring. These will typically drop right in. If they don't, you want to use a lip seal tool just to prevent any anything happening to the perimeter seal. Okay, grab your forward return spring assembly and just kind of hold it like this. And then lower it on. It is going to be a tight fit around the main boss, the center boss on that piston. Just be aware of that. All right, grab your little disc. And then let me set up the little compressor mechanism here. Just make sure you give yourself enough space to work, that's all. I'm actually going to have to do this kind of opposite-handed, so to speak. Normally I approach from the side where the camera is, but I'm going to see if I could do it this way without, slipping and falling and making a fool out of myself. Okay, it is going to take a little bit more effort, a little bit more of your body weight to compress this versus with the factory return spring, so just be aware of that. And then you want to make sure that you have this snap ring so that it's engaged in all 4 locking tabs on that return spring. Just double check it. Come out just a little bit here. That's right, that's magnetized. All right, everything looks good. And you can always recheck. And you definitely want to use this, this protecting disc, or this, forcing disc, or whatever the hell they want to call it, because the amount of increased tension or marginal increase in tension over the factory spring, definitely put that, top part of the cage at risk. All right, so you could check. All right, it's good. All right, now we're ready to fill in the rest of the guts. So for the sprag assembly, pretty straightforward deal. So here's your inner race / forward sun gear, sprag itself. And this will be tight fitting on here. I mean, that's normal. If it's real loose, then you don't want to use it. And then when you put this on, you want this race to be rotating clockwise and locking counterclockwise when you're holding this portion of the assembly. And I think I say this all the time, but for whatever reason, I can never remember which orientation it comes out of the packaging, if it's correct or not. Okay, looks like I got lucky there. So you're holding this should rotate clockwise. All right, lube up your bushings and front sun gear, and grab your bearing, and then grab your coast clutch. So steel friction, steel friction. I don't soak my frictions. I have a video explaining why that is. You can check that out if you're curious. Now, some of these coast clutch apply plates have an up, stamped into them. Some don't. Ultimately, it really doesn't matter. So here are those, little slits cut into the top of the sun gear. Again, a great way to facilitate more lube flow at higher RPMs to the planetary and the ring gear. Okay, forwards. I'm going to start with our wave plate. And we'll stack up the rest of the clutch. 5 frictions, 5 steels. These are brand new steels, so I always put a new steel module in all my high performance builds. I don't reuse the pre-existing steels, and that's just more of, again, a kind of a MECE thing, mutually exclusive, collectively exhaustive. I just want to be, dotting all my I's, crossing all my T's, kind of starting everything out at zero, so to speak, wherever I can. At least all my consumables, my wear parts. Alright, this looks like it's a little bit too far below that step there, so I want to check out, see what's up. And it's far below because I forgot my bottom steel. So let me put the sprag back in. So we have our waves plate. We have our bottom steel. Then we have our first friction, and then steel friction, steel friction. You know, I've built so many of these things, every once in a while I will get a little bit complacent or just simply overlook something, but, you know, I mean, we're all human and that happens. However, you always want to double check. I mean, if something doesn't look right, don't just continue on. Stop, you know, investigate, figure it out, make sure that it is right, and if it's wrong, just correct it. No big deal, but, you know, it's the main thing. You don't want to have to deal with this twice. I mean, at least not to the extent where you're dealing with it because of an error on your part. I mean, if this comes back because he wants to do more things or it needs to just be refreshed, that's one thing. But if it comes back because I screwed something up, then, well, that's quite another. Alright, so you want 30 thousandths minimum clearance in this thing, in your forwards. Alright. I'm going to put a little air into that clutch just to get it working, get it moving, and then I'll use some feeler gauges and we'll check clearance. And here's where you really want to pay attention to the forward clutch pack in particular. And the reason being is because the forward piston housing can sometimes be excessively worn, but it's not going to be real obvious to you, even on teardown inspection or cleaning. Sometimes a worn forward piston housing does not show up until you're at this point, drum reassembled, forward clutch pack in there, and you're ready to do your first air check. If you hear air like hissing coming from deep inside this drum, almost invariably it is the forward piston housing, and that's assuming you're applying the forward clutch pack. So you know, just keep that in mind. I mentioned it in other videos, but you know, it's always good to reiterate. So the forward feed port is going to be the middle hole on your input shaft, the middle feed hole. It's going to be between the second and the third sealing ring from the top. Okay, the air you're hearing is actually from this tip. This tip kind of sucks. I tore my rubber tip, so it's kind of what I'm dealing with. So I don't hear anything problematic coming from inside the drum. It's all coming from the tip. All right, just by looking at it, I can see that it's got appropriate clearance, but we'll check it anyway. And you do these enough, you really almost don't need to measure. So here's 30 thousandths. That fits in there comfortably. There's no way in hell it has more than the 50 thou max that, you know, is advised for this clutch, so I'm good with it. All right, now the real fun begins when it comes to installing clutch packs. So the 3/4 clutch can be kind of an adventure to set up, so to speak. And I say that because you never know what you're going to end up with a lot of times once you deviate from purely stock. So, you know, we have a completely different drum. We're using a different backing plate. We have a, you know, completely different apply plate. So we'll see what happens. I mean, it could be that I stack this up and I look and I measure and I'm like at maybe, I don't know, I'm going to just make this up now, I'm at like 80 thousandths clearance. and I don't like that. At 80 thousandths clearance, that's way too much. I want to be between 50 and 60. So what that tells me is I have a better chance of actually completely changing this clutch pack and going with like a 4L65E spec pack and just simply adding more frictions than I do getting into clearance with what I have. So that's what we have to do. That's what we have to do. You always want to be prepared for that kind of stuff. So if you're going to be working with one of these drums, I recommend you have a complete set of 4L60E spec steels and frictions, and then a complete set of 4L65E steels and frictions, so that you can mix and match to get that 50 to 60 thou clearance that you need. You can have 700R4 thickness steels in there too. I mean, that's fine also. Whatever works. All right, let me grab that ply plate. And you don't have to do any kind of heat treatment or You don't have to do any kind of prep work on these things. The steels, the apply plate. There's some cases where I will kind of scuff the colleens up a little bit, but I've found that I've not had to do that at all with the 4L60 or 700R4. I think I've done it with TH400s, but with this transmission, it's not necessary. All right, so where I need to measure, and I'll zoom in so that you can see this in a lot more detail, but where I need to measure is from this surface here, top of the drum, to the surface of the friction. So that needs to be between 50 and 60 thousandths clearance. So let me lower you, and then you can kind of get a much better view of what's going on. Now, first thing I want to do is see if this will even bolt to it. Yep. So we have movement. That doesn't mean that we're good with clearance. It just means that we would not be bound up if this was to be installed. Okay, I mean, it's a nice tight fit on there. That's great, but it's not so great for when I'm not ready to actually have it sit on there permanently. All right, I'm going to use a pair of calipers here, and what I want to do is go on one of these lugs. I'm going to do this 4 or 5 times around, and I want to just see how far this is going to travel. Actually, I might be where I need to be. So here is the little tip. That's how it looks, when it comes out. Yeah, this might actually work. I'm at 48 thousandths over here. That's roughly the 3 o'clock position. Let me check the 12 o'clock position. Same. 9 o'clock. Looks like I'm doing something wrong here. All right, when I backdoor it, I'm at 45 thousandths. Now I'm at 48 thousandths on 6 o'clock. When I say backdoor it, that means I literally extend this out a little bit and then just, seat it and let it tell me where it stops. Okay, last step before we bolt the plate on is we need to install the load release springs. So We have 10 of these in here, and although I didn't have them on the bench, because frankly they're out of sight, out of mind almost all the time, but you're going to need your original equipment spring retainer or spring housings. So all I do is just stick the Sonnax return springs in the OE housings. You know, I mean, common sense, right? So make sure it's fully seated. You can kind of twist them in, you know, clockwise if they're getting caught up, like this one is sort of, or you can just push it in. Either way, as long as it goes in, it doesn't matter. And then just go ahead and install it right there where it would normally go. All right, just make sure they're fully bottomed out. So there's 3 things that you do to prevent centrifugal apply of the 3/4 clutch. This is one of them. The high rate return springs and the 3/4 return spring assemblies, the second one. And then the third one is the orifice style bleeder capsule. So those 3 things will ensure that no matter how many RPMs you expose this thing to, it is not going to apply out of schedule. And that's the main thing you're trying to do when it comes to high performance. You know, last thing you need is the 3/4s coming on when you're trying to shift from first to second. All right, now your backing plate. Just make sure you line up all your bolt holes. Okay, there's going to be a little bit of repulsive spring tension, no big deal, just as long as you're aligned, you're good. So 55 inch-pounds. And I don't remember if Sonnax requires some sort of like torquing sequence. I don't think so. What I generally will do is just run these things down until they seat, and then, you know, I'll go, you know, maybe these 3, and then these 3, and then these 3, and then these 3, and so forth. But again, I don't believe that there's anything specific that Sonnax calls for when it comes to the order of, you know, torquing these little bolts up. I mean, the main thing is you just torque them to spec and, you know, don't miss any. Alright, I'm going to go right to 55 inch. So probably do is just start with this bolt here and then do these 2, then these 2, and then kind of just work my way around like that. Like I said, I don't know if that's specifically required or not. Let me do that. I'll do the middle one here. And here. And of course I'll check them all. Because no doubt there will be some that I miss doing it this way. Like I said, I may be overcomplicating it. All right, I think I went around. So let's go ahead and air check. Make sure that the third clutch applies normally. If so, we're pretty much done with the interior of the drum. Okay, you can hear the air coming out of that little orifice bleeder valve. You could also hear air coming out of my nozzle. I gotta replace this thing. But even with all the air coming out of pretty much everywhere, what you want to make sure of is that you're able to apply air, introduce air, and when the clutch pack is compressed, that you can't move it with your hand. Okay, that looks like it has about 50 to 60 thousandths clearance. I mean, that feels just like every other clutch pack I've ever set up in the 3/4s that meets clearance. So I'm happy with it. I think we're good. So last thing we need to do is install the turbine shaft sealing rings, and then we'll be done with this thing. Okay, as far as the sealing rings for the input shaft, I mean, pretty straightforward deal. You have your expander and your sizer, or at least you would have your sizer if you pulled it out of the drawer. So just 1, 2, 3, 4 expansion, and then just you know, maneuver them on and size them up. So this is no different now than any other 4L60E or 700R4 forward drum. You know, all I'm doing is just sizing them and then kind of putting them on the shaft, maneuvering them into place, and then sizing them there for the final time. Always check, make sure that they move freely. This drum, obviously, you would never suspect to be a problem. I mean, you check it anyway, but where you might see an issue with respect to these sealing rings getting pinched is on later model 4L60E drums in the 2006, late 2006 to around 2009, 2010 vintage. For whatever reason, those sealing rings like to get pinched. You know, the grooves themselves either collapse or they're undersized to begin with. I mean, I don't know, but what happens is the sealing ring is seized in the groove, and it starts to cut a groove into the inner, you know, into that inner sealing surface in the stator bore of the pump. And when that happens, you know, once the you know, the groove gets deep enough, fluid will start bypassing it, and you'll start slipping, and then eventually you'll have burnup, and the trans will need to come out and, you know, the stator at least replaced. And of course the input shaft's gonna have to also be replaced, unless you can take like a really thin file and clean up you know, where it's pinching it. I've actually done that before, where it was just a little bit, but just enough to cause the sealing ring to seize and you know, cut that groove in the stator. So I was able to salvage the drum, but I had to replace the stator. I don't know, this was like friggin' 4 years ago or whatever, but that's what happened. I only had to do that once. Every other time when you know, a drum came in where the sealing rings were pinched, it was, you know, pretty severe. You weren't going to fix that with a little bit of a, you know, filing or whatever. Okay, so this drum's done. I put my number 70 thrust washer, or excuse me, selective spacer underneath the thrust bearing. And then one other thing I'll point out is Sonnax does put the GM part number. This is 8678716. So 716, if you are familiar with my 700R4 4L60E drum differences video, that casting number, at least those last 3 digits, is how you identify a 4L60E drum. Every single drum installed into every single 4L60E, to my knowledge, has a casting number that ends in 716. I mean, it's the same number, it's the same drum, same architecture. The only differences are the input shafts. All right. So that's the Sonnax Smart Tech drum. Again, best drum on the market in my opinion. So if you have any questions, comments, go ahead and leave them below. Thanks for watching. There'll be a part 3 for this too, and that'll just be case reassembly, and I'll show you how to install and check band clearance on that servo.